All right, students, we're recording now. Before I get into the lesson, just a couple of announcements just right over there. Please take a look at my office hours. I'll have one in the afternoon today, Tuesday, and then there'll be another one Thursday afternoon for ninth grade, okay? Also, there is no learning activity today, mainly because we're getting into more geometry. This is a little bit harder. I know I struggle with it in high school. Actually, I really struggle with this stuff, okay? So I just want to ease it in a little bit more, make sure that you're understanding some points before we get into more problems with it, okay? Just want some time to process it. Another thing is retake times. Sign up sheet is on Canvas. You can go to the announcements from earlier this week, or you can go to the main page and there's a link as well, okay? But you're more than welcome to retake last PC, especially if you missed it and if you feel like you didn't do very well either, okay? Other than that, let's get into the lesson. Okay, so you should have a piece of paper out. Definitely get a piece of paper out. You're going to have to write these out to, memorize these a little better. And you'll need a calculator. Calculator is only for this first couple of slides, but for the rest of the lesson, we won't be needing it, okay? But just have it handy just in case. So let's look at this problem. I have two triangles here. It looks like it's a parallelogram. With these two triangles, I have triangle, let's write it as triangle FAR and triangle, I'll say TAR. Okay, one more little detail that I haven't really mentioned before is notice how F and T are kind of in that corresponding spot, right? When I said corresponding, I'll repeat this later again, but remember, corresponding is when you're looking at the position. So if I'm looking at my thumbs, those are corresponding to each other, okay? My pinkies are corresponding. Doesn't matter if I rotate it, doesn't matter if I flip it, my thumb is still going to be corresponding to it, okay? So let's go ahead and look at this. So I don't have anything given to you yet to really solve for this, but we can kind of put those pieces together of what we see, okay? Notice how there's dashes with this parallelogram, okay? I got dashes, two dashes with the parallel lines. Looks like FART. And then with their diagonals, it looks like I have, let me go this way, looks like I have one dash, okay? That given to you tells you that those two sides are congruent to each other, okay? So I need to be comfortable writing it out as, I could say FR, which corresponds with, let's see, TA. So FR is congruent to TA, okay? And I can also say that FA is congruent to TR. Okay, because of what's given, because of those double dashes, the single dash, those tell me that those two sides are the same, okay? They're congruent to each other. What's another detail we notice? Go ahead and look at AR. Do you see how AR is both part of triangle FAR and triangle TAR? Well, because of that, I know that just for argument's sake, when we're writing it out, I can say AR is congruent to AR, which is obvious because, it's equal to each other. It's the same line. So because of those pieces, okay, I can kind of say that this is congruent. The only way to really know that is when we're deriving, we need something that is not given but can be proved by evidence, okay? We'll come up with these, we call these postulates and theorems. We'll come up with these in a bit. But before we get there, we got to kind of build up to it, okay? But this is a good warm-up for us. I know from yesterday, a lot of you probably struggling with this learning activity. Let's just go ahead and look at this before we get into the rest of the lesson. But I want you to get comfortable with this and kind of have me to clarify what's going on here, okay? So when we have variables, again, we're still following all those rules that you learn. You learn about the vertical angles are congruent. You learn about the exterior, interior, right? The alternating interior angles and the alternating exterior angles, those are pretty similar with those definitions, right? But I'm going to use this as well and put these pieces together to solve for x. Okay, if I was to solve for x, well, because of vertical angles, I know that this spot right here that I'm drawing out at is going to be the same thing as angle 2, okay? Because of vertical angles. And because that makes that vertical angle that I just wrote in, and angle angle 4 and angle 3, all those create a horizontal line clearly, right? Because it creates that clear horizontal line, I can also say all that is going to be equal to 180, okay? All of this is equal to 180, 80 degrees. So if all those are equal to 180 degrees, I just need to sum all those up together, right? Add those all up together to get my answer. So I'm just going to be straightforward and say 7x plus 11 plus angle 4. Notice angle 4 has that right angle sign. That's 9 degrees, isn't it? Plus 4x minus 9 degrees. And that's equal to the whole thing, which is 180 degrees. Okay? Well, this is actually pretty straightforward where you just need to, let me erase those degrees for a sec, okay? We need to combine like terms. So I'm going to combine all the numbers together and then all the x's together. And then now it's just a two-step equation. So I look at my x's, I have 11x plus, looks like 11 plus 90, which is 101, and then minus 9, which is, should be 70, right? Let me just put that in my calculator, double check. Not 70, I don't know what I'm thinking. So I get my answer as 92, okay? And that's equal to 180. So now you know how to do this. We just have to first subtract 92 to both sides. So you get 11x equal to 180. Looks like I got 88. Divide. What's my answer? X equals 8. Okay, so that's my answer for x equals 8. And now I can throw that into my equations and find the angles 4, 3, 2, 1, and all those other ones, okay? I'm not going to spend too much time with that, but I just wanted to leave that with you all. Let's get into our lesson. So today's lesson, we have congruence of triangles, okay? I'm going to teach you about side, and side angle side, right? There are 3 letters that we need to clarify with these triangles, okay? But again, what we're trying to do today is to prove, just like with that do now we just did, prove those 2 triangles are the same, okay? That's the idea here. Today you should be able to identify and justify congruence of triangles. Again, I'm just slowly bringing this in, and then I'll put up a learning activity, and we'll just spend the rest of the week working on that, okay? So before we get there, we need to understand the angle sum theorem. Okay, I guess we can call it a third angle theorem. So if I have 2 triangles that are similar to each other, okay, and it's given that 2 angles of one triangle, looking at here, it looks like ABC. That triangle, 2 angles of those are congruent to the second triangle, DEF. Okay, notice those arcs that we see in that right angle, right? So if those 2 angles are congruent, then I know for a fact the third angle is going to be congruent to each other as well, okay? Notice how the total number of degrees for a triangle is 180, okay? So I know that if I can add all those angles on one of the triangles and equal to 180, those corresponding angles will also be the same for the other triangle, okay? So for example here, I see that angle A is congruent to angle D, right? Again, here's angle A. That's the same thing or congruent to angle D. Same thing with angle B. That's congruent to angle E as well, okay? Sorry, I need some water. Give me 1 sec. All right, sorry, I just had to take a quick water break. But going back, so angle A is congruent to angle D. Angle B is congruent to angle E. Because of this third angle theorem, I know that angle C has to be congruent to angle F, okay? So these have to be congruent or the same, okay? So now I know that I can add all those angles up, get 180, and then if I was to say find the missing angle, then I could use this theorem to kind of figure that out, put those pieces together, okay? So let's look at this example, okay? Let's use some stuff that we learned yesterday. So I have here angle EBD, or not angle, we have triangle EBD. Now let's say that's congruent to triangle, geez, I don't know what's going on with me today. Actually, I did a jog earlier. That really kicked my butt. That's congruent to triangle CBA, okay? Assuming those are true, we know that the third angle is also going to be congruent to the corresponding ones with each other, right? So let's just fill this in. So with both angle B on both triangles, those have to do 94 because vertical angles, and we know vertical angles are congruent. And then looks at angle A and look at angle D, that would be proven as alternate interior angles, okay? Remember, interior is between the parallel lines, and they're alternating because I have that transversal line cutting that right through, right? And they're from the opposite sides. So because it's the the alternate interior angles, I can say that's 21, okay? Same thing with angle E. I know that angle E has to be the same thing as angle C, okay? Well, because of that, both triangles are the same, or both triangles are congruent to each other. I know that one triangle, 5x, plus the other two angles have to equal 180, okay? And now I just got to do some algebra. That's 115. That's equal to 180. Get my calculator. So I subtract 115, subtract 115. I get 5x is equal to 65. 65 divided by 5 is 13. So I know that x equals 13, okay? Okay, let's go to the next one. So now we're going to start getting to those congruent triangles and those postulates and theorems, okay? We're going to try to start proving things a little bit more without using algebra, which is kind of hard. It was really hard for me, to be honest. I struggled like crazy in 9th grade geometry class, but you know, we got this. I understand your struggle too, and we'll get through it together, okay? But just like with congruent polygons, it's the same idea of congruent triangles, okay? So congruent triangles, well, reading that just says are triangles that have the same shape and size. So if they have the same shape and they have the same size, then we're good, right? They're made congruent if you even slide them, flip them, rotate them, right? It's the same thing as my hands. I can flip them, rotate them, move it whatever I want. But theoretically, right, the lengths and the angles, if I keep it like the same, right, if I move around and keep it the same, they're going to be congruent to each other, okay? So symbol for congruence, remember, that's the equal sign with the squiggle on top. Same thing with polygons. We're going to say the definition of congruent triangles. So two triangles are congruent if and only if their corresponding parts are congruent. So again, if the corresponding parts, so in this case, we could say angle A and angle D. So the two triangles are congruent if and only if those parts are congruent as well, okay? So if angle A is congruent to angle D, and then angle B is congruent to angle E, same thing with C and F, then we're good, right? Also with those sides, I'm going to show you the next slide, which is the proof of it, okay? Again, if this is a lot of information, pause the video, take some time to process it. But again, all this is saying is side AB, that's just the same thing or congruent to DE, right? And then you can see the other sides are congruent as well. And therefore, that means that if we assume that the two triangles are congruent to each other, then all those other parts have to be equal to each other, okay? That's all this is really saying. And that makes sense. I mean, if you use that in more practical words, right? It's basically saying that if they're both triangles, they're congruent, then everything else should be congruent as well, okay? So here's your first postulate. When I say postulate, it just means a fact that's true, something that we have to agree on before we can make sense of anything else, right? It's like saying maybe with sports, you know, I like playing basketball. It's like, you know, you have to make a basket within this ring to get 2 points, right? That's a postulate. Another one could be you shoot behind the arc. Well, that's 3 points, okay? That's a postulate that you always have to agree on in order to make sense of what's going on and to make sense in solving the situation, okay? So with triangles, if I have two congruent triangles, I can say that if the sides of one triangle are congruent, so notice those dashes again, 1, 1, 2, 2, 3, 3, right? If the sides of one triangle are congruent to the sides of a second triangle, then the triangles are congruent, right? I mean, I know that's easy enough, but you know, we use these postulates to prove a point here, to prove how triangles are equal to each other. But basically, all it's saying is if one side is equal to 3, then the other side is equal to 3. One the base is equal to this number, and the hypotenuse is equal to this number, then of course they're going to be congruent triangles. Okay, we call that side, side, side. Next one is side angle side. Side angle side is if the two sides and the included angle of one triangle. So notice the one on the left side, right? And they're congruent to the two sides and include angle of the other triangle, then they have to be congruent to each other, okay? So what that means is, notice those two dashes, right? You got the one dash, then the two dash, and then you have the angle there in green. So because both of them are side angle side, the other one is side angle side, those are congruent to each other. Therefore, the whole picture of the triangle, the whole triangle is congruent, okay? Let's put into this more example problems and stay with me with it, right? So I need to determine if these two triangles are congruent, okay? So here I have triangle, let's call it FSA. So I got triangle FSA, and I have triangle TSR. Okay? I need to show that this is congruent. Well, using what I just learned, is this looking like it's the side, 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 or the side angle side? Which ones are showing for you? What's given? So what's given to me is that I can see that I have side, side, I have those sides, and those sides equal to each other, okay? So therefore, because I know that all those sides are congruent to each other, then I could say that because of side, 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 and triangle FSA is congruent to TSR, okay? Let me kind of write these all out for you. Again, I'm just kind of front loading it and then taking a step, putting pieces together, and then putting it all together, okay? So again, I could say that line FA is congruent to RT. FS is congruent to TS. And lastly, I can see that RS is congruent to AS, right? Because all these three pieces are congruent to each other, I can derive this as side, 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 SSS, and say that triangle TSR is congruent to FSA. Okay, I want to say that I am consistent with my corresponding sides. Looks like I can switch around R and A. So A and R. Okay, so because I'm given all these congruent sides to each other, right? Those dashes, you just match them up. And because I have three sides of that triangle, I could say by side, 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 triangle TSR is congruent to FSA, okay? It's a lot of work, right? Again, you can always pause these videos, rewind them, and then double check. I know I might be missing some details, so put it in the comment section if you have a question on it, okay? Then I can reply to you. All right, let's move forward. So let's look at two examples. We got 4 left. I want to look at 2 of these and kind of talk about these, okay? So let's go ahead and see what we have and then try to derive using side, 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 or side angle side with these triangles to see if the two triangles are congruent to each other, okay? So looking at the first one, this is the boomerang one, just right over here, right? I can see that I'm given that I have this and this. So I can see that LA is congruent to UA. And I also have this other part, right? These other parts right here. Let's call it LG is congruent to UG. Okay. So it looks like I have a side, but I don't know if GA split between is going to be congruent to each other as well. But kind of going off, this kind of looks like that do now from the past, right? That we just finished. So because these are bisected together, because they're connected together, well, I can say that GA is congruent to GA as well. So we're going to call this side, side, side. So given that LA is congruent to UA, LG is congruent to UG, and GA is congruent to GA, well, it's the same thing. I can derive side, side, side. Therefore, triangle, let's call it LAG, lag, is congruent to UAG, triangle UAG. All right. So that's my proof there, and we're good to go. And that's all you got to do. Okay. You just got to label what you have and then interpret what you have into the postulates or the rules that we set, right? To prove that those two triangles are congruent to each other. Okay. Let's do another one. Go ahead and try pausing this video. I'm not sure if most of you will pause this, but just try pausing it, take a look at it, see what you have, and see if you could write it out, okay? All right. So I can see that I'm given two triangles here. We could say LE, and we could say that's congruent to TE because of those dash marks, right? And it looks like I have a right angle here. So I can also say angle E is congruent to angle E of the other triangle. And notice how we're doing this bisect again, right? It looks like because they're two right triangles, I know that's going straight up. So therefore, I can probably assume that that straight bisecting line is also the same, right? So because of EI is congruent to EI, we have here side, angle, side. Therefore, triangle L, let's call it LIE, lie, is congruent to TIE, tie, the triangle TIE. Okay, does that make sense? Hopefully that's making sense right now. Let's finish up these last two. I want you to go ahead and pause and see if you can get both of them together, and then we could talk about it, okay? I'm going to try to pause it myself and show you what I have. Ready? Go ahead. Okay, I realized that the last one we need to talk about. Kind of crazy. But let's go ahead and look at this first one here, right? We have here, looks like sides MS is congruent to TR, and angle S is congruent to R, and then SA is congruent to RA. So it looks like we have a side angle side, okay? So we're going to derive that as, because we have this given, I have side angle side, therefore triangle SAM is what I call it, is congruent to triangle RAT, okay? If you tried the last one on your own, good job with it, but we got to really talk about this, okay? Because remember, I only gave you two things, side angle side and side, side, side. So if you look at here, I can see that, well, I have angle N, let's use capital N, that's congruent to angle I, and then we have that right triangle, or that right angle, angle M, is congruent to angle S. We also have angle T, am I doing this right? N, M, yeah, angle A is congruent to angle T, right? Well, because of this, I have an angle, angle, angle. Angle, angle, angle. So angle, angle, angle actually cannot prove that this is congruent to each other. Mainly because if you think about it, I can have the same angle triangles, but does that mean the sides are going to be the same? Okay, if you said no, you're thinking correctly, because I can have a big old triangle, right? This big old triangle that's like life size and everything. And I can have this really, really small triangle that are proportional to each other. They do have the same angles, but they aren't congruent to each other, okay? They're similar, but they're not congruent. Again, I'll say that again. You have a bigger triangle compared to a smaller triangle. Those aren't the same because the sides aren't the same, right? So therefore, those are not congruent. Therefore, this is not, so I can say triangle man is not congruent to not congruent to triangle. Let's call it sit. Yeah, let's call it sit. Okay. So does that make sense? Again, I think I need you to pause this and go back and rewind a bit to understand that, well, when you have an angle, those sides can be a lot different. They're not necessarily the same to each other, right? Because you can have a bigger one and a smaller one, or vice versa, and have something proportionate. But remember, congruence means they're exactly the same. The sides are the same and the angles are the same, okay? But other than that, let's move forward, and that's it for today, okay? What we learned today was identify and justify congruence of angles. Just a reminder, here's everything there. Office hours, no learning activity today, and the retakes. Go ahead and sign up for it, okay? But I hope this was a good, straightforward lesson. We'll just keep practicing, using some more of these postulates that I've kind of prepared for you all, okay? And I hope you have a great day.